So I was saying that addition polymerization occurs in 3 stages, and to explain them, we are going to take an example. So to explain those stages, consider polymerization. Consider polymerization of ethene. So as highlighted earlier on, to polymerize ethene, we combine any moles. Any means there are many of them of ethene in the presence of an appropriate initiator. So this is the general representation of an organic initiator, preferably peroxide initiator, in the presence of high temperature, but we shall specify that temperature as the session progresses. What is it in particular? High temperature and the pressure. So step one is the chain initiation. If you recall, this is somehow similar. It is somehow similar to halogenation of alkenes. So what do we have under chain initiation? So under chain initiation, we have the following. Under chain initiation, we have the reaction. In this case, which is the polymerization process. The reaction. The reaction is not in. The reaction is initiated by homolytic cleavage. Reaction is initiated by homolytic cleavage. A moment. Initiated by homolytic cleavage. Homolytic cleavage of the organic initiator. The process is initiated by homolytic cleavage of the organic initiator to form so homolytic cleavage results in formation of highly reactive radicals. Initiated by homolytic cleavage of organic initiator to form highly, not high, to form highly reactive radicals. So there is this term homolytic cleavage. Homolysis, if you recall from the introductory bit of organic, we mainly refer to breaking a bond between two atoms of near equal electronegativity values. So if my peroxide is ROOR and I want to carry out homolysis, I write it as follows. So each atom takes the electron it contributed. Oxygen does that. Also this oxygen does that. Therefore, form two radicals of OR. That is for chain initiation. Then step two, we have chain elongation. which is the chain propagation. So to propagate the chain, this is chain propagation. To propagate the chain, in this process, the radicals, not the radicals, sorry. This involves, so it involves attack, of the monomer unit, involves attack of the monomer. By the way, it has two sub-steps, but you are going to see them. So the first sub-step is that it involves attack of the monomer unit by one of the radicals, formed in step 1. By one of the radicals formed in step 1. Involves attack of the monomer unit by one of the radicals formed in step 1. How? Don't forget that our monomer unit in this case is ethene. That has that representation. So this is attacked by one, not that, one of the radicals. So one R or R. So this is the radical polymerization. In particular, also here we carry out homolysis. Carbon takes the electron it contributed. This carbon also does the same, however, it brings its one electron so that it combines with that of OR. As a result, we obtain CH2 with a dot, followed by CH2, which I am linking with the OR. So that is the first sub-step. Then the second sub-step under propagation is that this radical, the process of the monomer being attacked by radicals continues. So this radical, in particular this one that I've just synthesized, this radical attacks a new, or this radical attacks a new monomer unit. It attacks a new monomer unit, and the process attacks a new monomer unit, and the process continues. The process continues so that the polymeric chain grows. The process continues so that the polymeric chain grows. We are going to see what that means. So that radical attacks a new monomer unit, and the process continues so that the polymeric chain grows, i.e., so we have, what have we just formed? So we have just obtained CH2 with a dot, then CH2 OR. This attacks a new CH2 double bond CH2. So this takes the electron it contributed, molality cleavage. This carbon does the same, however, it brings its one electron so that it joins with that one. Therefore, look at that carefully. If you observe it carefully, look at it very well. Okay, let me, for simplicity, let me start with the alkene instead. Otherwise, some of you lack a chemical eye. So for simplicity, allow me start with the alkene. So this is attacked by the radical CH2, CH2, OR, and this has a dot. So carbon takes the electron it contributed. Also, this carbon does the same, however, it brings its one electron so that it joins with that one. As a result, we form CH2 with a dot, followed by another CH2, followed by another CH2 that links up with another CH2, CH2 OR. So I have said previously, that the radical, this radical which was formed here first. Why is this thing failing to respond? Oh, this radical, that one, it attacks a new monomer unit, and the process continues so that the polymeric chain grows. Now, also this radical that has been formed attacks a new what? It attacks a new monomer unit so that the process continues. That's why we keep on using many things as the chain grows. Therefore, let me illustrate the third one. Then, for the first time, I will consider a general case. So, I have said also that one continues to combine with a new one that is CH2, combining with the one that has just been synthesized, CH2, 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 OR with a dot. Therefore, also in this case, carbon takes the electron it contributed. This does the same, however, it brings its one electron so that it combines with that. As a result, we obtain CH2 with a dot, followed by CH2, followed by another CH2, followed by CH2, 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 OR. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, that's what we form. So the process continues. However, for propagation in general, this is what we have. In general, we don't continue with because we don't know where we shall stop. We don't know where we shall end. So we just have a general representation. So in general, for propagation, in this case, for chain elongation, for propagation here, we have CH2, our ethene, CH2. In general, that ethene, many of them, so I put N here. Many of them combine with CH2 CH2 or R. Any of them combine in the same way. So this takes the electron it contributed. This does the same, however, it brings its one electron so that it combines with that of carbon. So in general, if you look at these subsequent products that have been forming, have been following, which ones in particular? If you look at this one, if you look at this one, that one, the one I've underlined, also that one, which other one, and also this one, which was underlined. So in general, we keep on adding CH2, 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 CH2. Therefore, in general, we shall form CH2 with a dot, CH2 with a dot, followed by CH2 like that. Then followed by another CH2, but this is very long. It is a very long thing. So I put close brackets and N, meaning that it is the repeating unit. It is the unit that keeps on repeating itself. Then this side you put OR, and that marks the end of chain propagation. Step 3 is the chain termination. Chain termination. So chain termination also has 2 sub-steps. What are they? So the chain reactions, are terminated as follows. The chain reactions are terminated as follows. How? So the first one are terminated as follows. It is either way terminated as follows. Either way, either by coupling reaction. So what is coupling reaction? Either by coupling reaction, i.e. recombination. Coupling, I mean either by coupling reaction, i.e. recombination, of terminated by coupling reaction, i.e. recombination of polymeric chains of radicals. Yeah. So what in particular? Look at what I have formed under propagation. It's here. This is what has been synthesized under propagation. That one in general. So to terminate things, radicals of this kind, they recombine. So we have this combining with another compound of the same form. So in general, this is what we have. So we have obtained, allow me write that compound as follows. I hope you are noting and you are following, because I don't want to refer to it a lot. You have it there, you are following. So we have that one that I have circled, combining with another one with whom they have the same representation. Therefore, allow me write that as is RO. If you look at it very well, followed by CH2, CH2, followed by CH2, CH2 with a dot. Then this combining with RO, CH2, 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 CH2 with a dot. So we are combining those two. So what do we get? This is coupling. Coupling. We are putting them together. So in simple terms, to put these together, what I am doing, I am bringing this so that it joins with that. That's what I'm doing. Therefore, we have R. Oh, I think this will not be enough space. We have RO followed by CH2, CH2, then N, CH2, CH2, like that. Then to that, I am adding on another one. But if you are following very well, you'll see that after this first one, what comes next is CH2, CH2, then CH2, CH2, NOR, like that. And this is the same thing as so you see there are a lot of CH2s. There are a lot of CH2s. So this is equal to, it is the same thing as having RO, RO, then followed by CH2, CH2. So let me push. I want to push the CH2s inside. So here we have N. Followed by, I want to push that thing. Let me highlight it here in black. I want to push this thing in black inside. I want to push it inside of that chain. Hope you've seen. I want to push it inside of that chain. Let me wrap it off. So if I want to push it inside of that chain, you agree with me that we shall have CH2, CH2. So this now will become Ne plus O. This now shall become, sorry. Ne plus 2 OR. Like that. Still, I want to convince you that this is the same thing as having RO. These CH2s can be put together so that we have N plus 2. So that becomes CH2, CH2, hope I'm on. 2N plus 2 OR. So you were writing a map of it. That is, if you refer to what I said earlier on. We are writing a map of it, just a summarized version, but that is how it looks like. So that is case one. We can terminate via coupling. So either by coupling reaction or by disproportionation reaction. Or by disproportionation reaction. So what is disproportionation? Or by disproportionation reaction, i.e. self-oxidation, and the reduction. Self-oxidation and reduction. So in particular for disproportionation here, i.e. self-oxidation and reduction, in particular here, one polymeric radical, loses a hydrogen. In particular, one polymeric radical loses the hydrogen atom. One polymeric radical loses the hydrogen atom. That is transferred. Loses the hydrogen atom. Is transferred to the other. Is transferred to the other polymeric radical. So one polymeric radical loses a hydrogen atom that is transferred to the other polymeric radical. This is what I am referring to. This is what I'm referring to. This is what I am referring to. So I have still we refer to the other radicals of propagation because that's where we stop. So from propagation, we form the RO CH2 CH2. Oh, this is what we formed. Yeah. Sure. What's this? N CH2 with a dot. Now this is combining with the RO CH2 N. CH2 with a dot. Yeah, those are the products that were obtained from elongation, from propagation. Those were the products that were obtained from propagation. CH2 with a dot. They are those ones. Now for disproportionation, I've said that one of them loses a hydrogen and it is transferred to the other. For example, this one. Look at this one in black. But this one in black, this one here. for it to lose a hydrogen of you are observing. So particularly here I have CH, H, CH2 dots. That's how it looks like. Particularly that ending where this thing here, I'm just exposing it because I want to show how hydrogen is lost. So still here, hydrogen takes the electron it contributed, like that. Also that carbon takes the electron it contributed, like that. So what do we form? So hydrogen takes, carbon takes. Hope you are following. This is what I've said. I've said hydrogen takes the electron it contributed. Carbon also takes the electron it contributed, like that. So what do we form? We form CH with a dot. There is a bond here, CH2 with a dot. Then plus a hydrogen that has a dot. Now that hydrogen that has a dot, it is transferred to the other radical. Then these two dots which you are seeing here, this dot and that dot, they are put together to form a second bond. Therefore, for disproportionation of these two, we obtain the following products. We shall obtain RO, CH2, CH2, N, then CH, double bond, CH2 plus a hydrogen transfer to the other, RO, CH2, CH2, N, CH2, CH3. And that is addition polymerization for polyethylene. It occurs in 3 stages: initiation, propagation, and termination. So I'm coming with another example.